you stopped sharing your
screen. Okay, here we go. So, so 0, right? And then we have negative pi and pi, correct? Asymptotes. Center will go on the axis. Okay, now I have a negative out front. That means to the right, instead of going up, it's reflected down, and on the left, it's reflected up. So it's the opposite. Okay. Okay. For the next one, I'm going to add to this so we get a vertical shift as well. So you see it's a negative tangent x plus pi over 2. I'm going to put in here, like just continue, plus 2, just so we get a vertical shift as well. Okay. All right. For the period, b is 1. So it's just pi. For the phase shift, you take x plus pi over 2 and you set it equal to 0, just like you did for sine and cosine. So x is negative pi over 2. That is your phase shift. Okay, now a lot of questions I've been getting is, what if you have a phase shift? Do you still do the inequalities the same exact way? Yes, yes, yes. And I purposely made the phase shift here pi over 2, which is the same as your like inequalities, right? Because it's independent. One is independent of the other. So you still take that term x plus pi over 2 and you still put it in between negative and positive pi over 2.
Okay.
Yeah.
Is the phase shift negative pi over 2? Or
yes, yes, sorry. You know? Okay, so I'm going to level with you guys. So every morning I have 2 cups of coffee. But guess what? This morning I had 1. And then afterwards, like, I felt okay. And I'm like, you know, maybe I could get away with just 1 cup. Because, you know. But clearly not. So I'll know from now on I'm not cutting down my coffee. Listen, that's my only vice, okay? It's my coffee. And that's cool. Like, I don't have any other habits that are detrimental to me. And, you know, I'm gonna take my coffee. I like my 2 cups in the morning and 1 after my lunch. And, man, that's it. Never again. Okay. So, you should see me when I'm hungry. I can do no math.
I don't know if you can say that sentence at a Jewish school.
Which one?
You said never again by your coffee.
Okay, so minus pi over 2 everywhere. All right, so what do we get now? Negative pi, x pi.
Isn't it 0?
Oh my God. I should go have my coffee now. Okay, here's what I'm going to do, guys. Look at what I have here. I got espresso beans. Trader Joe's. All right. Just going to pop a couple of these. Okay, so you know what happened right before you said that? I was like, wait a minute, negative pi to pi, that's a length of 2 pi, but the period is 1 pi. So, you know, so that's how you can also catch yourself. Okay, so let's go here. I'm going to go from negative pi, 1, 2, 3, 4 to 0. Okay, now let's just do the points and then we'll do the vertical shift. Halfway here is negative pi over 2. The first quarter point is negative pi over 4. And then negative 3 pi over 4. Now, let's put in the asymptotes because those are never going to change.
Miss Malikian?
Yeah.
If you don't know, like, let's say you forget the things, could you look at the unit circle? Like, how it...
You can do that as long as it matches with the unit circle, sometimes you get crazy things like pi over 16 or something. You know what I mean? But if not, yeah, you could always go on the unit circle. Okay. So now, remember how there is a vertical shift here of +2? That means this time, instead of that center point being on the x-axis, now the axis of oscillation has moved up to y = 2. That means that center point is on that axis, y = 2. Everything else is the same. There is a negative out front, so to the right, I go down 1 from that point. To the left, I go up 1 from that point, and that's how it looks. Yeah.
What about the phase shift?
Mm-hmm.
Do we have to move over?
We actually did move over, because without the phase shift, we would have gone from -pi/2 to pi/2, right? But look at what happened. Now we started from -pi, so we did move over. What happened is, when we did this, it fixed everything for us, right? That's why we do that.
So what's the point of writing the phase shift if you don't actually need it?
You don't need it to graph, but the point of it is, it's something that you need to know how to find, because later on it'll come in handy for other things. Like even when you're not graphing, you should be able to extract the phase shift from a function. You know what I mean?
Yeah.
Okay, Max, did you have a question?
It was the same question.
Okay. All right. So let's move on to cotangent. Cotangent is pretty much the same. It's 99% the same. The difference is cotangent is cosine over sine. So now I'm dividing by sine, meaning cotangent is undefined every time sine is equal to 0, right? And where is sine equal to 0 on the unit circle? At 0, at pi, at 2 pi, and so on. So at each of those points, the cotangent has a vertical tangent. It is a vertical tangent, but it has vertical asymptotes. So look, there is a vertical asymptote at 0, at pi, at 2 pi, okay? So that's what's different here, is that the asymptotes are on the pi's, not the pi/2's. The period is still pi because I go from 0 to pi. But now, take a look. Let's get a unit circle going here. This, if I highlight it in red, that's the interval from 0 to pi/2. From 0 to pi/2. On that interval, cotangent is positive, so it's above the y-axis. Next, this is the interval from pi/2 to pi. From pi/2 to pi. In that quadrant, cotangent is negative, so it's below the x-axis. How does that matter to us? Because it's the opposite. When I have the center point, the cotangent will go down on the right and up on the left. Okay? Okay, now somebody's going to ask me, so wait, is it just the reflection of the tangent? Not really. It might look that way, but the boundaries are shifted. Okay? So it's like you shifted by pi/2 and then reflected, then yes, it would be the same. Okay? But yeah, de facto, like they look like they're upside down. Okay? So because the asymptotes are at 0 and pi, what you need to know is for the cotangent, you're going to put the boundaries from 0 to pi. Okay, so that is the difference. Okay. It's like having 4 siblings and each of them is a little different, right? Sine, cosine, tangent, cotangent, like you guys know. I have 3 boys, they're each a little different. Very similar in other ways though, you know? Okay, so let's do one of these. So how are things the same as tangent? How are they different? The period is still pi over b. So when I have y equals cotangent 2x, this period for this one is pi over 2. Now to graph, I take the 2x and I make an inequality. So far so good. But now because it's cotangent, I gotta go from 0 to 2 pi, 0 to pi. Divide everything by 2. And I'm going from 0 to pi over 2. So here, I'm going from 0, 1, 2, 3, 4, pi over 2. Okay. The halfway point, if you forget how to do it, and if they're crazy numbers, remember that green is halfway between 0 and pi over 2. So it's half of pi over 2, which is pi over 4. The green is pi over 4. The red is halfway from 0 to pi over 4. So that's half of pi over 4, pi over 8. This one here, the blue, the way you can do it, if you can't see it right off the bat, is half of the green, pi over 4, plus pi over 2. Okay? And that'll be 3 pi over 8. So there is another way you can reason through this, and every year I have a student ask me if they could do it this way, and yes, you can. Listen, you guys are like sophisticated math students at this point. You have lots of tools in your belt, right? So look, this is, the first point is 0, and then the next point is pi over 8, right? And because these are going up by equal increments, each increment has a length of pi over 8. So that first point is 1 pi over 8. Then another pi over 8, that's 2 pi over 8, which is pi over 4. And then 3 pi over 8. And then 4 pi over 8. If you feel like that's easier for you, okay. I mean, like, listen, it's totally cool with me, right? This one isn't as straightforward when you're not starting at 0. So like each method has its own benefits, you know? But again, sophisticated math students, right? If you can do your arithmetic a different way, you can do it a different way, okay? Okay, so here's my asymptote and my asymptote. So x equals 0 and 2 pi. Remember, you need an x equals there. Pi over 2. I need another bean. Okay, no vertical shift. The center point goes here. Okay, now cotangent goes down on the right. So to the right, I go down 1. To the left, I go up 1. Boom.
So do you treat cotangent like negative tangent?
So de facto maybe yes, but there is technically a shift because one starts at negative pi over 2, one starts at 0. So maybe like, in between us, we might say that, but like, like if you were ever like at a math party, we wouldn't really get caught saying something like that. You know what I mean? Like, you'll never be invited back. Okay? All right. Yep.
I know that we haven't done any with the amplitudes being anything other than 1. Can you show how it would be if it were?
Yeah, of course. Yeah. So suppose this was a 3 cotangent to x, right? Then instead of going down by 1, it would just go down by 3. 1, 2, 3, and then 1, 2, 3. So it looks like flatter almost. These are more tricky to draw because students want to put curves in there, but it's like, it just gets flat. It's like you pull on the 2 ends and you just like extend, like you just stretch, right? It's like stretched. It's like a Snickers bar. When you stretch, right, it lessens the curves versus increase them. Okay? All right. Thank you, Gabi. That was a good question. Okay. Okay, we did sine, cosine, tangent, cotangent. Now we do secant, cosecant. All right. The secant and cosecant, right? So we've talked about this. Cosecant is 1 over sine. Secant is 1 over cosine. So again, you've got this idea that you're dividing by something. Anytime you're dividing by a function, vertical asymptotes. So cosecant has asymptotes when sine is 0. Secant has asymptotes when cosine is 0. So there is nothing new in graphing secant, cosecant. They can see you from the mirror. You want to say hi?
No.
That's my first grader. He's on break. I have their schedules up here, like the 1st and the 5th and the 7th grader. So, I can anticipate them coming. Okay. So there's nothing new here. So what you do, suppose you're going to graph cosecant, right? That's 1 over sine. So what you do is you graph sine. Look, this is sine, right? And then the book just kept going, so you get like a nice little pattern here. Now that's just a regular sine, just like you did in 4.4. There's literally nothing new there. Then what you do, you say, okay, this is the axis, right? Like the x-axis or the axis of oscillation, no matter whether it's the x-axis or if it's shifted. You find the axis of oscillation. And then you look at where sine, the graph of sine, hits the axis of oscillation. Over there, you draw asymptotes. And then once you draw the asymptotes, you put in u's at the above and below sine of x. Okay? So, and then for secant, you draw cosine. You look at where cosine hits the x-axis or the axis of oscillation, and then you do the same thing. So how about this? Let's do a couple here, because no matter how many times I tell you this, like, you just have to do one. It's really a lot simpler if you just do one. The one thing though is the actual graphs look like this. So they actually have like empty space in between, right? So it's reversed. Remember how sine and cosine only existed between -1 and 1? This is the opposite. It only exists above -1 and above +1 and below -1. Okay? All right. So look here. We're going to graph 2 cosecant 2x. And here, I've done something that is for sure, going to get me uninvited from the next math party. These were supposed to be y equals, because how could we graph something that's not a function? It has to be y equals. Okay. I want to graph 2 cosecant 2x. For that one, I'm just going to use sine of 2x. Yeah.
I'm sorry. Can I just leave for 1 second?
Yeah. Of course. Yes. Thank you for telling me. Yeah. So for the period, this is b. You can either use the one from cosecant or from the sine. It's the same. And because this is like sine and cosine, we're going to go back to 2 pi over b. So 2 pi over 2 is pi. Okay, now we're graphing y equals 2 sine 2x. Okay? And so we do this. And then this is going to go from 0 to pi. So when you graph, this is what you would have graphed, right? The left part of this. I'm sorry, the right part of that. I graphed on the computer and I just did another one, which you're not going to have to do. I just did 2 periods so that we get a little bit of practice. Okay?
Do you do that? It's like greater to or equal then because they're not asymptotes?
Okay, so I knew somebody was going to ask this. So this is a little bit of a controversial thing, right? When you're dealing with the sine, you're allowed to do less than or equal to. For the cosine, technically we should do less than, not less than or equal to. So again, this is one of those things where we're just going to do it here, but we're not going to get caught with it outside. You know what I mean? I don't mind, like for my purposes, when you're doing sine and cosine, whether you do closed or open. Yeah. Okay, so then you look at all the points where this hits the axis.
Mr. Malikian?
Yeah.
Sorry, why are you using 0 for the first number in your the last one equal to? Because we're using negative pi over 2.
That's for tangent. This is sine.
Oh.
Yeah. So those are where it hits the x-axis or the axis of oscillation. We put our asymptotes there. So where are these asymptotes, right? We have an asymptote at 0, at pi over 2, at pi, and then also they're negatives. So plus or minus pi over 2, plus or minus pi. Now, for the cosecant, all you do is draw the u's on top and bottom. What you have to make sure of is at the peak of the sine, right? The sine and the cosine have to touch there. And then you just have to make it follow the asymptote all the way up, right? It's almost as if they go like almost vertically up. And then here too, just make sure they touch at the minimum over there. And then you just extend down like this.
Should it be like a quadratic formula, so it goes up 1 over 1, up 2 over 2?
No. You don't have to, you can just eyeball these. But yeah, it doesn't follow the quadratic pattern. Yeah.
Okay. Why do you have to do the inequalities if you are just going with the asymptotes by where it is?
The inequality is to let you basically put in these points on the 5 critical points. Like it's so you know where to start and where to end on the x-axis.
So when you don't have the already anyways, then you know where it's going to
Exactly, because you're usually going to have them like number 4, right? You're going to have to do everything from scratch. Was there another question?
Yeah, I had a question. I had
Yeah.
2 questions.
Uh-huh.
The first one is we don't have to worry about how it's 2 cosecant.
Oh, well, technically we did, because when I graphed, you see how it goes up 2 units?
Oh, okay.
That's the amplitude, yeah.
And then the second one is, would you like us to always draw the sine wave, or?
Technically, you don't have to. It's there to guide you. It's not really officially part of the graph. I know students sometimes prefer to do it without. It's up to you. Right? Okay, so let's do this other one too. But you know what? I think I'm going to add a vertical shift to this one as well. What do you guys think? Let's add a vertical shift of 3 here. So let's go up 3 units. So let's do negative secant 2x plus 3. Okay? So for that, I'm going to graph negative cosine 2x plus 3. The parentheses there are optional. Okay? Because if there are no parentheses to begin with, then you know it's a vertical shift. It's outside. Okay, so for the period, it's 2 pi over b. Okay, and then I take the 2x and I go from 0 to 2 pi. And that'll go from 0 to pi for us. Okay. So, because there is a vertical shift of 3, I'm gonna put the x-axis a little bit further down. Okay, so we're gonna go from 0, 1, 2, 3, 4 to pi. And that's pi over 2, pi over 4, 3 pi over 4. Now, this has a vertical shift of 3. So I go up 3 units and I put in the new axis of oscillation. Okay? All right. This is a cosine. It's actually a negative cosine. So at the first point, it's going to start where? 1 unit where? Down, right? Because it's negative cosine. So it's going to start here, then on the axis, then up, then here, then here. Okay? Are we okay with this so far? Let's graph the cosine. It looks like that. Now that's miles away from the x-axis, right? It's not touching the x-axis, but it's okay. It's all about where does the cosine cross the axis of oscillation. And that is this point and this point. So I draw my asymptote there. Okay. Now, for the secant, I have one here. Okay. And now look at what happens. The second U, or branch, is going to be left incomplete, right? Because of how cosine's graph looks. And that's not cool. We can't do an incomplete like that. So what I'm going to ask you to do is to put in manually one additional critical point, either to the left or to the right. It's up to you. So take a look at this. This interval, right, is pi over 4. It seems like each box is going up by pi over 4s. So to the left, that would be negative pi over 4, right? So I just put that one in, and then I can complete that cosine. And now I have another asymptote there. The reason is I need to get a full, U or whatever you want to call it. Okay? So now the asymptotes are, at negative pi over 4, pi over 4, 3 pi over 4, and so on. 2 or 3 is enough.
Did you do the asymptotes for the problem above as well?
Yeah. Remember, so we went and we said it was at like negative and positive pi over 2, negative and positive pi, and so on. Okay. So that is secant. Okay. So it's like we're building on, stuff, Okay. Question? Yes, no?
Do we have to write all of the values?
You have to write, okay, so you have to have always 5 critical points. And then for the secant, 1 additional one, yes. Okay. Roy, did you have a question or you're just stretching? Okay.
I was just stretching.
Other questions? Alrighty. Well, with that, I will let you guys go. I will update the lesson plan and I'll put it up for you guys. And it's bonus right now, so you can grab a snack or do whatever you want, okay? Let me stop sharing here. Okay. So have a fabulous weekend, guys. Obviously, you can stay if you have questions. Otherwise, you can go.
Thank you.
Bye.
Thank you.
Bye. Hey, Abby.
Oh, hi. I was just wondering if when you record the meetings, if you could upload it so we could go back.